Hi everyone, welcome to another instant model video where we're looking at real-world problems that can be solved by machine learning. And I show how to quick and easy build production-ready models for these use cases in PerceptiLabs. Today we'll build a model that will help us find anomalies in magnetic tiles, for example on an assembly line. To do that, we build a classification model on different types of anomalies you can find. Then we'll train it, go over the results, test the model, and by the end, we'll have a production-ready model with over 80% accuracy in just under 5 minutes. Let's get to it! First thing first, let's take a look at the data. We have a few different folders here with different anomalies inside of them. We have the blowholes, the breaks, the cracks, the frays, the uneven, and also the ones with no anomalies inside them at all. If we take a look at the data itself, we can see two different types of images. We have the JPEGs as well as the PNGs. The PNGs are there in case you want to segment what part of the image has the anomaly. However, in this case we're doing only classification, which means we'll just be using the JPEGs. There's also a lot more images inside the free folder than in any other folder. So what I did in the CSV is just select the first 130 of these free images. Now that we know the data, let's get to building the model. I've already loaded the data into PerceptiLabs, so all I need to do is to select it and then define the dataset. Here we want to make sure that we have images as inputs and categorical as targets. This is because we want to do image classification to detect what images has what anomalies. The model I'm going to build is a MobileNet model, where I use MobileNet as a pre-trained component, so it goes a lot faster both for training and to get higher accuracy. MobileNet only accepts RGB inputs though, so the little trick is to change this convolution to have 3 feature maps. We'll then connect everything up to the model and make sure the last output layer uses softmax as its activation function. When the model is ready to train, we have set the training settings. Make sure to have cross entropy here, and then start running the model. You can already see how we have a training accuracy of 0.6 or 62%. This is thanks to MobileNet doing a lot of feature extraction and heavy lifting. Validation already at 80% as well, or 75%. You can also look at this prediction for each class, where we can see that we're predicting 22 or 52 of the zeros correctly, and then just a few misclassification, as says 1, 1, and here we have a little bit more misclassifications. It tries to predict the 2s or the 1s as 3s a lot of times. We finished training at 83% validation, 88% training accuracy, which is not bad. We can then test the model. We can do a confusion matrix run to see exactly how it predicts on the test data as well. Here we can see it does mostly really good classification. It confuses this class a little bit and has some misclassifications over here, but in general, classifies everything as it should. I hope you enjoyed this instant model video. Just as a reminder, if you want to try it for yourself, PerceptiLabs is completely free for developers and is available for download on our website. If you have any issues, visit our forum or reach out to me directly at our Slack channel. You can find all information, including the dataset we used today, in the description below this video. Please subscribe to our channel and watch more instant model videos.